Okay, so we're going to do a set of notes here on what's called solving right triangles. And in each of these cases, you're going to be given one side of the triangle and the measure of one of its acute angles. And you're going to have to find the measure of the other side. So at first, we're going to work what are tangent problems. Okay, so let's see how this kind of plays out. Let's build a right triangle here. Okay, well, that's kind of messy. Let's fix that up a bit. Okay, and let's say that this is 30 degrees, the angle A here, and that the length of this side is 14, and I want that side. Okay, so in relationship to the 30-degree angle, this is the opposite side, and this is the adjacent side. So we know that the following is true. The tangent, sorry, I don't want that as a 30-degree angle. I actually used in your notes, and it's easier to see this as 33. So let's make sure that we got that is a 33-degree angle. Okay, so we're going to say that the tangent of that angle, the tangent of 33 degrees, is the opposite x over the adjacent 14. Okay, so when these equations set up and the variable is up top, it's really easy because you just take the other two values and you multiply them. So this is like doing cross multiplication. So you get 14 times the tangent of 33. Now, how do I find the tangent of 33? Well, back in the day, they used to do this by using tables. There's actually one of them in your textbook. I don't advise doing it that way. But back before there were graphing calculators, we would have to do this using a table. But now we actually have a little bit of modern technology, so we're going to use a graphing calculator to do this. So let me bring up my calculator. Okay, so here's my TI-84 graphing calculator. And something that I have to be aware of is that the default mode on the graphing calculator is not degrees. So I have to hit the mode button, and the first thing I want to check before I do any of these problems is this setting that says radian and degree has the degree setting highlighted. So I'm going to put my cursor over top of degree, and I'm going to hit enter. And once I have that, I know that this thing is working in degrees as the unit for angles as opposed to radians. Okay, so now I'm going to go back to the main screen. Now what I needed to be able to do is to find 14 times. Now if you look across the middle of the calculator here, all three of the trigonometric functions are there. The sine, the cosine, and the tangent. So we wanted to take the tangent of 33 degrees. And this tells me that the length of that side is approximately 9.0917, whatever the linear unit is. So I'm going to go back to my picture and see what I mean by that. So what we have here is that given this picture, x is approximately 9.0917. Okay, so this tells me that if this is 14 and this is a 33-degree angle, then the length of this side has to be really close to 9.0917 units. Okay, so this is how you handle it when I have a tangent situation of the opposite over the adjacent and the variable is in the top. Now we're going to look at a tangent situation where the variable is in the bottom. Okay, so we're going to look at another right triangle here. And just to keep things simple, throughout this lesson, we're going to keep this as a 33-degree angle over here at angle A. Now this time, we're going to give this a value. So we're going to say that this is 8 units, okay? And we don't know what this is. So if I think about the tangent ratio, I say that the tangent of 33 degrees is the opposite 8 over the adjacent x. Now note, this time the variable's in the bottom. When I do that, I just take these two values and I switch them. And if you think about that long enough and hard enough algebraically, that's going to make sense, because I'm multiplying both sides by x and I'm dividing both sides by the tangent of 33, and that's going to put the x over here, and it's going to be 8 over the tangent of 33. So I want to know what that's approximately equal to. Now, one more time, I'm going to go back to the calculator to look at this. Okay, so what did I want to calculate there? I wanted to calculate 8 divided by the tangent of 33. I do it all in one step. That way I don't make round off errors or anything like that. And this tells me that that's approximately equal to 12.3189, about 12.3189. Okay, so let's go back to the problem and see what's going on there. Okay, so what the calculator just gave me here was that the length of this side is approximately 12.3189. So what we've got here is that if that angle is 33 degrees and the length of this side is 8, and this is a right triangle, the length of this side has to be really close to that 12.3189, and I don't know how many, this could be inches or feet, miles, something like that. Alright, so that's the tangent. In each of the tangent problems, you have the opposite and the adjacent in play. Okay, so now we're going to look at sine situations. So, same 30-degree angle, 33-degree angle. Nothing unusual there. This is going to be 33 degrees at angle A. Okay, so in my sine example here, we're going to have a little bit different setup. Okay, not that much different, but we're going to have different sides involved. So we're going to say that this side is the unknown, and the hypotenuse now is 22. So because I have the opposite and I have the hypotenuse, this brings up the sine. So if I set up the equation, I know that the sine of 33 is the opposite x over the hypotenuse 22. Again, the variable is up top. If the variable's in the numerator like that, then I just cross multiply my way out, and I get x is 22 times the sine of 33. I would dump that into my calculator, and that's going to give me approximately 11.9821. So if this is 22 and that angle measures 33 and this is a right triangle, this side is going to be approximately 11.9821. Okay, so we're going to work another sine example, and this time we're going to get different information, right? So this is still going to be 33 because we're just keeping things simple here, not complicating things. The length of the opposite side is going to be 6, but I don't know how long the hypotenuse is. So I'm going to set that up. The sine of 33 is the opposite 6 over the hypotenuse x. Now, look that the x is in the bottom. Last time that was there, what we do is we take these two things and we trade their places. So we get x is equal to 6 over the sine of 33. That's something that I can enter into the calculator, and when I do, I get that that side, that hypotenuse, is now approximately 11.01647. So if this is a right triangle, and this is a 33-degree angle, and this side length is 6, then this one has to be 11.01647. Nothing too off the wall there. All right, so the last thing we have to do yet then is to look at some examples with the cosine, right? So let's take a look at that. Okay, so let's get a couple of cosine examples here. All right, so again, I'm going to build that right triangle. And again, just to keep things simple, we're going to keep this as a 33-degree angle. Okay, so the length, this is a right triangle. The length of this side is x. The length of the hypotenuse is 15. I know this is cosine because I have the adjacent and the hypotenuse in play. And the cosine of 33 is the adjacent x over the hypotenuse 15. Where's the variable? The variable's in the top. That means I'm going to cross multiply my way out. X is equal to 15 times the cosine of 33, which, according to my calculator, is approximately 12.5801. Okay, so if that's 15, and that's a 33-degree angle, and that's a right triangle, the adjacent side is going to be approximately 12.5801. All right, so one last example, and then we're done. Okay, so again, another cosine example. So again, this is going to be a 33-degree angle. I know now that the adjacent side is 7 in length, but I don't know the hypotenuse. So again, the cosine of 33 is the adjacent over the hypotenuse. Note where the variable is. It's in the bottom. When they're in the bottom, we switch these two things. And we get x is equal to 7 over the cosine of 33. And at this point, I can put that in the calculator, and I get 8.3465. 8.3465 is the length of the hypotenuse if the adjacent leg is 7 and that angle is 33. So trigonometric ratios, you can see, are useful to find one of the sides of a right triangle if you know another side and you know the measure of one of the acute angles. All right, so that's it.